You are listening to the Break Time Tech Talks podcast, a bite-sized tech podcast for busy developers, where we'll briefly cover technical topics, news snippets, and more in short time blocks. I'm your host, Jennifer Reif, an avid developer and problem solver with special interest in data, learning, and all things technology. We have lots of snow and cold temperatures where I am right now, so I am staying warm and enjoying the view from inside. Data loading, cleaning, and prepping always feels like the longest pole in the tent for any application or system that I build, and this week was spent trying to wrangle a larger data set than usual into a Neo4j database. I found some big walls that I hacked my way through, and this is a data podcast after all, so I'll share some tips and tricks to hopefully help you avoid the same pitfalls that I ran into. Then I'm very excited about a preview feature in the upcoming version of Neo4j. I will share some info about that as well as some resources to help you find out more. I may have mentioned, or you may have seen me present with a Goodreads book data set in the past that has books, reviews, authors, and user information. However, I had only been working with a smaller version of that data set, and I have been wanting to test my skills and some Cypher optimization techniques by loading the whole thing. I just hadn't really gotten around to it yet. So that was my challenge for this week. I wanted to combine Ollama models, local models, and some new Cypher AI procedures, which in the recent version of Neo4j, it now supports Ollama through configuring the base URL. The new Cypher AI procedures will take advantage of that new vector data type that I've mentioned in previous episodes in Neo4j and allow you to generate as well as store the embeddings with various types of AI models in a Neo4j graph. To set this up, I needed a few things. I needed to add the AI procedures to the dbms.security.procedures.allow list configuration property in the neo4j.conf. So I needed to go into the configuration file for Neo4j in a local database instance and set it to allow list these AI procedures. Then I needed to tweak the base URL for the GenAI procedures in order for it to use the OpenAI-like format and just call the Ollama model under the hood. So I needed to configure that in the genai.conf. It was a little bit frustrating, actually. I was kind of expecting and hoping that it would be a configuration property in the procedure itself, but you actually have to set this in the configuration file, in a separate configuration file for the GenAI procedures. So I set that. And then I also, while I was in these configuration files, I increased the memory and the page cache for my local instance because I knew I was dealing with a larger set of data. I wanted to make sure I had plenty of processing power for that. And I tossed in the APOC extended library and the configuration for APOC to read local files just in case, but I didn't actually end up using this in the end. After all this configuration, the first problem that I encountered was a 404 error. And come to find out, the /v1 that is commonly used at the end of the Ollama OpenAI compatible URL actually isn't necessary. That gets tacked on within the procedure itself. And so you can just take off that /v1 at the end of the OpenAI compatible endpoint. And so you just have basically, I think it's the localhost and the port number there for the base URL. You don't need the v1. It adds it later. Then after I got through that, I got an input length error when I was sending a batch of text properties to Ollama. So I checked the various links of the book descriptions, the text that I was trying to send over, with the MXBAI embed large model, which was the Ollama model I had chosen. And I checked the context model, the context window for that model, which is 512 tokens. Not very large, actually. I tried a substring of that, and that still wasn't working. So I ended up moving to a model with a larger context window, like the Nomic embed text, which has 8,192 tokens. Much larger, much better for longer documents. I was still getting the error, so I tried a single basic test call just to narrow down my criteria a bit, and that worked. So then I tried a tiny batch of 3 descriptions, and that one worked. We're making progress. So I went back to modify my original query into smaller batches, and that failed, even with batches of only 5 descriptions at a time. I went down another path of maybe I need to chunk up this text into much smaller pieces and try to send these smaller amounts over. So I took a slight detour here and needed to calculate the number of chunks that I was going to need based on how long the book description was and so on. And the calculation of the simple division didn't work because it divides into a whole number. For instance, 1,364 divided by 1,000 leaves you a result of 1, which leaves off the remainder. So I tried the round function with a 0 decimal precision and the ceiling for the rounding, but that still wasn't working because the inner division was still chopping off that decimal value. I finally found an ugly hack that was then thankfully refined by some colleagues to multiply one of the numbers in the division by 1.0, which basically turns it into a float value, keeping that precision of those floats. So it retains the decimal. Then use the ceil function to round up and convert it all to a whole number using 2 integer. So yes, it was slightly hacky. I wish there was a nicer, cleaner solution for that, but that was working. I ended up going back and abandoning the chunking though because of the maintenance and the added overhead. Every time you chunk up a book description into, let's say, 2 chunks, 5 chunks, 30 chunks, whatever it is, you're having to maintain that, add additional nodes and relationships in your database, and that's just added overhead. And this was already a relatively medium-sized data set. And the book descriptions weren't pages long. We're talking several thousand characters max. So this isn't pages and pages of documentation here. I did query the distribution of the descriptions that were longer than 10,000, 15,000, and 20,000 characters, and there really weren't that many in each one of those distributions. So coming back to the input length error, after messing around with the various batching configurations, I started to wonder if it was the overall context window on the model, or if somehow the model was preventing batches that were too large. The batching had to be small. After tweaking with that quite a bit, it really didn't seem much value to actually do any batching. I created a query that didn't do the batching, and I got an out of memory error. Great. New error here. So even after tweaking the instance configuration to size up my page cache and my memory and the transaction size a bit, it was still struggling. I went down the rabbit hole of let's do some query optimization, dig into this a little bit more. I added on the explain keyword to the front of my query, which means that it dives in and pulls up the query plan without actually running the query in against the database. It just gives you the query plan of here's what the Cypher planner will probably do for this query. And it showed the query plan, and I found an eager calculation in there, which is not a good thing in a Cypher query. It's there for a reason. It's helpful in some cases, but generally you don't want eager when you're dealing with large amounts of data. I will link a blog post that I wrote a while ago. There's also some other documentation out there about the Cypher eager, but I would highly encourage you to check it out. And if you're doing a bunch of Cypher and graph database queries, I would definitely recommend to try to narrow that down as much as you can to avoid the eager. So I needed to try to remove the eager calculation there in the middle of the query plan. I worked with a colleague to help me clean up a couple of other things about the query, and I ended up being able to trim out the eager, which was a super win for me. Even after all that, though, I was still getting the error. So I took another slight detour down the contents of the book descriptions themselves. They're in various languages, which can vary in token counts per character. This is something I didn't even think about when I was working with this, is depending on the language that you're in, the token counts add up to a different number of characters depending on the base type of the language. I got the distribution of all the languages that were in the book descriptions, went down the rabbit hole of maybe refiltering by the language code property, but that was actually inconsistent. Only about half of the entities in my database had a language code property, and it was really hard to filter that out and try to trim down and find the non-Latin based characters because of that code structure. The language code was not something like a list of languages. You'd have to manually go through and put together a dictionary of those codes and so on. That would have been really difficult. So we started down the hole of, well, maybe we ought to try like a regex, and that was met with limited success because of the variety of possible characters that started the string. So I went back to the drawing board and decided to use some error logic that one of my colleagues had suggested. And you can use error logic in Cypher to skip the ones that fail and just see where I ended up on that front. It turns out it did about 83% of the embeddings, which is great. That's sufficient for my first pass. That'll get me most of the way there, and then I can clean up and hopefully go back and filter out and fix the ones that remain. But what I ended up doing for this is using at the end of my Cypher statement with the call in transactions, you can add error or retry logic there. And basically what I added was on error continue. It will try to do the transaction, but if something fails in that, it will go ahead and just continue and move on to the next transaction. So it skips and just goes to the next one, basically. With that pass, I was able to get most of the book descriptions embedded, and that was a great thing. And then I was able to move on to the next piece of my data load. And hopefully I will be able to go back and correct the ones that didn't make it in the future, but this does get me closer. Also, as a heads up, I will be at JFocus in Stockholm next week. So if you're planning to attend, I hope to see you there. The content piece I want to highlight this week is the vector search with filters in Neo4j version 2026.01 preview. This is a blog post that is out on Medium now, and it's all about a new filtering in Neo4j vector search. I am really excited about this feature because instead of doing a two-step GraphRAG process like I have been doing, basically where you have a query or a method or something that will call a vector search, get the results back in your application, and then go out and do a graph retrieval query and pull the refined results from there. This can do it all in one shot. So you could write a single Cypher query that will do the vector search and do the graph traversal or other type of filtering you might want to do, all in a single call to the database. There are 3 approaches to this new Cypher filtering. First is the vector search plus filters. You could do like a keyword filter and weed out results that don't necessarily fit specific criteria you might be looking for. Then you have the Cypher after vector, which is the post filtering. This is the one that I traditionally think of as GraphRAG. You do the vector search plus a retrieval query on top of that. And then you have a Cypher before vector search, or a pre-filtering approach, where you can do a Cypher statement and based on this subgraph, then do the vector search within that space. The blog post mentions and walks through each type of these scenarios and when you typically want to use one or another type of search, shows examples of each one of these as well. This is really super helpful. And then also does a performance benchmark test for all 3 and show how each one holds up over the scale of number of embeddings and the filtering types. The last thing I want to highlight is the context graph demo app. I mentioned the blog post on the context graphs last week, and this is the demo app. I finally had a chance to sit down and at least play a few minutes with it just to see what it was all about. What I really like here is the level of detail. When you ask questions in the chat about the data set, it comes back with a ton of detail about things, and there's a variety of analyses that the application will give you. And then of course you can explore deeper into certain aspects or others. It also brings back a part of the graph for some of the questions so that you can actually see and poke around on the actual entities and properties themselves, and then provide some other information about the schema and kind of the behind the scenes with some links to GitHub and other resources. I hope to be able to explore this a little bit more over the next few weeks, but this at least got me started. I find that nothing teaches you skills faster than exposure and experience. So even though the data loading was challenging this week, I emerged with some wins and learnings that I can use for the next time around. Debugging is a really tough and yet satisfying skill to refine. Neo4j also continues to improve its features, and I'm really looking forward to trying out the new vector search with Cypher filters that's coming up in the next release. As always, thanks for listening and happy coding.